In this video, as part of switching or Boolean algebra, we're going to see in particular consensus theorem in this video. Okay, what consensus theorem states is, if you have a variable, let me take x, and if you have it like this, xy plus the x variable's complement times another variable z and plus y times z. So let me summarize here. Okay, if you have a variable and its complement in two product terms here, we call this one as a product term, right? And this one as a product term because it's product, right? Logical product. So x and x bar, and this is one variable and this is a different variable, and for this particular equation, okay, for this particular equation, if we have these two different variables, product term, okay, sum to this, okay, logical sum, then this equation can be written as xy plus x bar z. Okay, this is what it states. Okay, let us see the proof of it. Okay, to prove this, take the left hand side equation side, okay, xy plus x bar z plus yz. Okay, now to reduce this equation, if you see this last term, it doesn't have x term or x bar term which is present here. So what we do is we're going to multiply this with 1, this particular term. So multiplying it with 1, we can say x plus x bar, which is 1, right? So substitute this 1 with x plus x bar. So it becomes xy plus x bar z plus yz times x plus x bar. So we can rewrite this as xy plus x bar z plus xyz plus x bar yz. Okay, so if we write this xy, take these two terms, okay, and take these two terms which have something common in them. Okay, so xy plus xyz plus x bar z plus x bar yz. So we can rewrite this as xy, if you take common, 1 plus z, right, plus x bar z 1 plus y. 1 plus y is 1, right, the resultant, and 1 plus z is 1. So we can write this as xy plus x bar z. So we have proven that xy plus x bar z plus yz is equal to xy plus x bar z. Okay, now we know that if you prove this equation, if you take the dual of this whole equation, that equation will also hold true, right? So let us write the dual of it. X plus y dot, right, x dot x tick plus z times y plus z will be equal to x plus y, okay, and of x bar plus z, right? So these two will be dual to each other, these two equations, and they hold true. The equality will be true. So this is just the proof of it, right? Now in practical problems, how you're going to use this is, let me show you. Okay, suppose usually if you have a variable, suppose say take any variable, okay, suppose you have a variable a and you have some content here, okay, it may be 2 variable or 3 variable product, you're not worried. Plus if you have a bar times some other thing, suppose this is let's take xz, okay, anything, okay, this is like y p, okay, and p is also variable, suppose assume, okay, now plus you have x z y p, okay, this can be written as x times a times xz plus a bar times yp, right? The basic thing is, if you have a, okay, let me go back to this. If you have a variable and its complement here, okay, and if you have two independent, I mean different things here and here, or even dependent, however it is, the product of these two, if it is in the sum of this one, this term can be taken out of the equation. That is the whole point. Okay, this is called consensus theorem, and we have proved it, and we have seen it dual one also. Okay, thank you for watching.